Here we go. Okay, other questions on anything, this worksheet, anything else? Two F. Great question. So why don't we know the maximum number of games played in the 2019 to 2020 season? So notice this is a histogram of the number of NBA games played, right? And if you look at this first class, let me change my color here. So this is class 1 right here. How many games have been played in here? Well, here's the lower limit. Here's the upper limit, sort of. So this class is 0 games up to, let's say, 4.99999 games, right? Technically, it would be exactly 4 because they don't count half a game. If you play in the game, you've played, I think, no matter how much time you spend. So there are 38 players who played between 0 and 5 games. Does that make sense why you don't know the maximum? Right, so up here, this is where the maximum is. I think this is the 13th class. I don't know, I should count again. Here, these 20 players have played between 65 and 69.9999 games. It could be that there's a player, one of those 20 players played 67 games, and that's the maximum. We just don't know. So the real answer here is we don't know the actual data values. We don't know the data values. It's a histogram, and it's a grouped histogram. Or these we've grouped the players into classes of amounts of games they played. What else? Y'all feel good about that? In case you weren't able to read the lines that had no distinction in color, black was the top line, Hispanic was this middle line, and white is the bottom line. And this is the imprisonment rate per 100,000. This is another statistical graph about disparity between races, right? Because it's essentially the same graph up here. We've got the percent of the population and then the percent that are imprisoned. And you kind of expect things to match. So what's F? Find the absolute difference in the values from parts B and E. Let's see. So for the imprisonment rate here, what did you say? Oh, this is awful. This is one of those ones that'd be nice if they had the thing over there. 1,000, 30, 40, 15. Let's see. So I think, right, this line is 1,100, 1,200, 1,300, 1,400. And so we're looking at slightly above, good gracious, what is it? It's between 1,200 and 1,300. So let's say 1,250. Does that seem what you all had? By the way, the interpretation of this number, there's 1,250 Black US residents that are in prison for every 100,000 US residents that live in America. So if there were 1 million Black US residents, we would multiply this number by 10, and we'd have the number of people imprisoned. So this is the wrong answer. Did everyone catch that? I did it wrong. This is the 2018 number. And I was supposed to do the 2010 number, which is this one. Well, that looks like it's exactly 1,500. Yeah, thank you. Got it. So then absolute difference, it just means subtract these two, and if you get a negative number, make it positive. In other words, really, usually we do new minus old to see what's the change in time. And based on the numbers I have here, by the way, if your numbers are slightly different, don't worry about that. This would be 250. So interpreting this value, we would say there are 250 less, 250 per 100,000 Black US residents imprisoned. Let's see. Well, that sounded terrible English. How about this? the imprisonment rate for U.S. Black residents decreased by 250, let's say, inmates per 100,000 residents. 100,000 Black residents. Does that make sense? Oops. Well, okay then, let's talk about 3.2 and 3.3. Unless you all still have another question, I'm gonna
Eric,
start.
we did not get to 3.3.
Perfect. Let's talk about 3.2.
So you can concentrate on 3.2.
Love it. 3.3 is just a repeat of the other two, so it's no worries. Okay, so here's 3.2. Recall that in 3.1 we did measures of central tendency, which was we had 3 words for it, right? Average, center, and I guess central tendency. And center is the big word that's going to show up later that we're going to use all the time. And they were the 3 measures: mean, median, and mode. And mean and median are the 2 best ones. And you picked mean if your shape was symmetric, and you picked median if your shape was skewed, and you could determine the relationship of, or determine the shape of the data based on the relationship between the mean and the median. That was a super fast review of 3.1. So what you learned, I guess Thursday, was measures of dispersion. Another statistic or parameter based on what you're getting. And this one, there were 4 things that you learned. I'll list, oh wait, there are what, 3 words. So measures of dispersion, spread, or variability. Those all mean the same thing. Oops. The one we're going to use the most is spread. But be prepared. Variability. Be prepared to know any one of these 3: dispersion, spread, variability. But most often, we're going to say describe the data set, and you're going to list the shape, the center, and the spread. That's coming up in 3.5. And then in chapter 8, in chapter 8, we're going to list those 3 things again, but it's always going to be the same thing every single time. It's going to be symmetric, mean, and the standard error. Okay, so these measurements, there are the not so useful one, range. It's super affected by outliers. It's just the maximum minus the minimum. Then there is the, there is the standard deviation, which is a good one, and it's good for symmetric data sets. There is the one that you use in grad school, which is variance. We don't really use that here. We just make you aware of it. There's a connection between these 2. And then there's one that you didn't really learn about, but was probably just mentioned. We're going to look at this in 3.5, I think, or 3.4, the IQR, or interquartile range. Now, all of these are in StatCrunch. You don't need to know the formulas. You don't need to know necessarily how to find them. Let me take that back. You need to know the formula for IQR. We'll get there, because we might not give you a data set. And if I don't give you a data set, you have to know the formula for this. These 3 come in 2 flavors. Well, they all come in 2 flavors, but the statistic version of standard deviation is S. That's the symbol for it. Remember, that means it came from a sample. Variance is S squared, and there's nothing for these 2 in terms of special symbols. If we're working with a parameter, meaning we perform this calculation from a data set that is a population, you have sigma and sigma squared. And then these squared things actually kind of have meaning, although here they're symbolic. And what that is that the variance is equal to the standard deviation squared. So if I hand you the standard deviation and I say, what's the variance? I give you the number for it. You just square it and you get variance. And then if you're a fan of algebra, take the square root of both sides and you get that the standard deviation is equal to the square root of the variance. That's just a handy little thing to put in your back pocket. It's nice and helpful sometimes. Part of the problem, part of the reason we ignore variance in this class is that the units are squared. So they're kind of meaningless in terms of interpretation. Like if the thing is money, you'd have square dollars as the units on it. So what does that mean? The other thing, generally speaking, the larger the number, the larger the spread or the variability, meaning kind of how far apart the data values are. We then get to two kind of important things. Let's see, I want to put them in, not that one. I want to put them into, or show the page numbers for them. One of them you're just going to use over and over and over, and that is interpret the mean and standard deviation in context. I'm sure Cindy told you this too. This thing is super useful. Put this script in your reference sheet. We're going to do a bunch of them today. And that is, you're going to say this. You're going to take the context from the prompt and put it there. You're going to type in the mean here, or you write the number for the mean, and then you're going to write the number for the standard deviation here, and you're going to provide units, either with the mean and the standard deviation or just after the mean. If you're a person that wants to save on ink, you can write this plus or minus instead of give or take. They mean the same thing. Yeah, there goes my light. What page is this? Page 86. You want that in your reference sheet, the sentence structure, not an English class, so everyone can write the exact same sentence and we will be very happy. Sometimes creativity gets you in trouble. The other thing is we provide the first like mathy definition of an outlier. So unusual is a definition for symmetric data sets. And there are two options. One is the data value has a probability less than 5% of happening. And the notes say this way better than what I'm writing, but I just want to highlight this. Two C's? I don't know. I can spell happening. I can't spell occurring. There we go. Or the one that you're going to use more often here today, I think, more than 2 standard deviations away from the mean. Again, this only applies for a symmetric data set. More than 2 standard deviations away from the mean. You're going to talk about this a lot. I'm going to ask multiple times. You'll see it in the worksheets. Is this value unusual? And you're going to use either of these two definitions. If you know the % chance of that happening from the empirical rule, you'll state this one. Yes, it's less than 5%. No, it's more than 5% chance of happening, so it's not unusual. Or if you know the number of standard deviations away from the mean it is, you're going to state that one. It's 2 above the mean, so it's not likely to happen, or it's unusual. Or it's 2 below the mean, so it's unusual. And then for not symmetric data sets, we don't call the values unusual, we call them outliers. We're going to learn this definition a little bit later, but it's related to the IQR. So we'll say here skewed data sets. And we're going to give you, I'll just label it here. We're going to give you a lower fence thing and an upper fence definition. And that's how you talk about quotes unusual values for these skewed data sets. One other little note on this sentence structure. That sentence structure only applies for symmetric data sets. And there are several problems in the worksheet where the data set is not symmetric, and we ask you to interpret the mean and standard deviation in context. Just do it. Just do the sentence structure and know that that sentence has no meaning, that it's not actually true. So that kind of bothers me a little bit, but it's good to practice at least the sentence structure. Last thing, this was a beefy section. I totally get why you only did 3-2, because there's like 1,000 things in here. I had the same issue with my in-person class. So we only got through the 3-2, and that is the empirical rule. And really, so the empirical rule is this, I think specifically what it's referring to is this thing. But when I think about the empirical rule, I'm thinking about this thing with a this and this, and this, and blah, blah, blah. Now, you do not need to draw this on your own reference sheet, because if you look at the reference sheet material that is handed to you, in other words, Appendix A, page 263, here's the empirical rule written out for you. You get to bring this with you to the midterm and the final, and you are 100% going to use this. So don't worry about writing, just know it's here. And when it comes, we're going to start right here with practice problems. When it comes to using this, these things are fixed. They're always the same. Always this, right? So if I hand you a blank normal curve, you can fill out those percentages right away. We understand that that's approximately what they are. Your job is to figure out these numbers down here. That's your job. So let's remember which assignment you're turning into me for chapter 3-2, and that is worksheet 3. So let's go to worksheet 3. We'll start there, and I'm sure we'll have time to jump back to whichever one you're turning into Cindy, and we can look at that one as well. This is a good place to do lots of practice. Yeah, let's do this first. I think this is good. It's a great reminder of StatCrunch. You are going to need to enter all of this into StatCrunch. So let's start there. This is page 498. And I think with a group of 8, let's do, that's a 3 in each group. Let's do it, shall we? Shall we do groups? Or does that just sound terrible to you all? What is recognizing?
Agreed with Laura.
Okay. That's 2 out of 6. Should I infer that because 2 want to stay here, all 6 of you would like to stay here?
Honestly, I'm sicker than a dog. I would really appreciate staying here.
Okay, that's 50%. Should I then infer now that the other 50% want to stay here? We'll stay here for sure. Awesome. So let's do, that's 2/3. Sorry, you other 1/3. I guess we don't care about you now because that's more than a majority. Is that what we call a supermajority? All right. So let's enter this, and then let's do 5 minutes where you work on this, and then we'll come together and talk about maybe what's happened, or if you got stuck or something. I'm going to type these. I'm going to mute myself and turn off my camera so it doesn't look like I'm watching you. And then I'm at least going to type this in StatCrunch. And y'all don't let me forget, we need to talk about StatLab before the end of today. Okay, here's a real timer. Let's do 10 minutes. Set a timer for 10 minutes. Yeah, crunch. I'm just going to do it anyways, even if you don't want to say it. So we go to stat.
Yes, please.
Good, there we go. Summary stats, columns. You're going to live here for chapter 3. Chapter 4, you're going to jump in here to regression. But for chapter 3, stats, summary stats, columns. In fact, let me think here. Whatever, we'll stick with this for now. Yeah, I think almost this entire class lives in the stat menu. Okay, so we're under columns. Now notice we want 2017's mean, median, standard deviation variance and 2022's mean, median, standard deviation variance. So we can select both of those at once. Notice that's, you may not have done this. That's why I renamed those columns. Instead of variable 1 and variable 2, I've got the years listed. It just is, in my opinion, kind of helpful. And then the things we want are in here. But first, I want to know, what did you all say for D? What was your answer? Parameter or statistic? And the reason I ask is because that matters for what we pick over here for variance and standard deviation. They are different formulas depending upon whether something is a parameter or a statistic. So shout it out. Is this data set when we calculate from something from this data set, are the results a statistic or a parameter? And if you have no clue, shout that out too.
A parameter.
How did you know?
Because it's not really giving the data that we need for it to be a statistic.
So when we calculate something, well, what determines something being a parameter versus something being a statistic?
Statistics are a sample. This was not a sample.
How did you know it wasn't a sample?
Why you gotta ask so many questions?
Okay, well, okay, so it's actually a statistic. So thank you for playing.
How?
Yeah, how? So to answer that, we have to determine, is this a sample or is this a population? This box of stuff. Anyone know the answer?
I think Reagan nailed that one because it doesn't say all.
It's not from all the countries.
That's context. You know, this is not all the countries on planet Earth, right? Nice, Ashley. Yeah, now you all, I'm going to highlight something, and don't feel terrible about this. You're going to get really good at this in the future, but I'm not seeing where my thing is. Look at this word right here. What do y'all think about that word?
I totally overread that. Didn't even see it.
Right? No, it's so easy to do that. No one feel bad that it explicitly states that this is a sample. Do not feel bad about that. Just know that it's often listed there when it's a sample. That it will say, hey, the following random sample of countries, blah, blah, blah. But Reagan, you're totally right. Reagan, you're totally right that if there had been all countries, then this would have been a population. Okay, so this is a statistic. Notice this, when I grade this worksheet, here's where I often have to do -1 because people don't write the explanation. And what's the explanation? Data came from a sample. The data came from a sample. Okay, how we feel about that? Does everyone feel good? Yeah.
I'll get it through repetition eventually.
Oh yeah, 100%. No, that's what these early ones are about. And this is one of those things that as you take more time reading the problems, because my guess is you do what I do often is you skip that part and you just jump right to the question that says, hey, what type of variable is country? You're like, oh yeah, I know that's qualitative, right? But you might have forgotten to read this prompt. And in this course, reading the prompt is key. Where did my, okay, that was 10 minutes. Where did my tools go? Okay, whatever. I want to be able to erase, but I can't find it. All right, so now that we know that, we have to point something out, and we should jump back here. Oh boy, this is getting crazy. So let's jump back here real quick, and let's make a note that in StatCrunch, when we are calculating a parameter for standard deviation or variance, we use unadjusted stdev or unadjusted variance. That is a population calculation. Whereas if we're doing the statistic calculation, you're going to select just standard deviation or just variance in StatCrunch. And let me show you in StatCrunch what I'm referring to. Swoop. Swoop.
They've seen it, but repetition is good.
100%. I always forget this one too, so don't feel bad. Now, one of the things is with mean and median, there is not a different formula between a statistic and a parameter. They're just add them all up, divide by how many. But here's variance, here's standard deviation. These are the two for sample. And then if we scroll down here, here's the unadjusted variance and unadjusted standard deviation. That would be used for a population. And you're probably going to do it in some worksheet or some stat lab problem at some point. Maybe the chapter 3 review, this is going to show up. Maybe it's going to. Get ready. Now, is everyone good with being able to select these things that you need? Remember the control click mess and how that could be a pain if you're not careful with that. No, I'm messing up. So mean, I'm doing them in the order we wanted them. Notice that they show up over here in the order you click them. In compute, and here's everything I needed for those two things. I need to make my mouse cursor bigger. Are those the answers you got? Man, that seems different than, maybe not. Do we all agree? I double checked my numbers, but that doesn't mean I'm right.
Yes, except I rounded to 2 decimal places like it said.
Perfect. Did you all do that too?
I was gonna ask about that. So the standard deviation and the variance both need to be rounded up.
Correct.
Okay.
I'm going to be picky and say just round, because round up in the math world means add 1 regardless of what this is. And it's going to show up in chapter 9 that when we say round up, we always add 1 when we drop decimals off.
Yeah,
So,
just round.
yeah, just stick to round. And I'm just being picky about that because it's going to show up later. You did it right. The words almost don't matter, but they do matter later. So there's that. Okay, so let's do it. Let's maybe write that down. Here's the numbers I would have had. So for 2017, 4.20 and 4.01, and yes, standard deviation 1.10. Does that blow your minds? The 8 causes us to add 1 to the 9, and 9 plus 1 is 10, so it becomes 110. And then 1.21 there. And then what? 613, 132, fail, fail, fail. And I don't know how to erase right now. Oh, they're all wrong. And now I'm just, oh. Where did it go? Just write those numbers down. Oh, man. Okay, any question? Did everyone, what did y'all say? Did everyone say quantitative here and then dollars per, it should really be US dollars per gallon. You know, because China doesn't use actually none of these people use US dollars. Well, the United States uses US dollars. And probably all of these other countries would be using liters instead of gallons, but these were all converted. What'd you all say for F? Which one had more variability in gas prices?
Okay, does variability mean like, is that connected to variance?
Yes.
Okay. So 2022.
Good. In fact, variability is the word we use least often for spread, right? This was one of the options. We could say spread, variability, or dispersion. All three of them mean the same thing. All three are measured by these four measurements. And I don't know who said that, but good job, because I wasn't watching. Good job, whoever spoke. The larger number is the one with the higher availability. If you note, if standard deviation is larger for one of them, then the variance will also be larger. So these two will always match. If you think about the inequality here, yes, 2022 has higher variability than 2017. All right, the big one. How did you all do with G? Anyone want to type their sentence into chat or read it to us?
Come on, guys, you can do it.
Or maybe you need a little more time to do it.
I didn't get to that. I'm a slow typer in numbers going down on StatCrunch. So I am just now doing it right now.
Well, let me be quiet for 5 minutes while you all try that one. Set a timer for 5 minutes.
So remember to use your script when you're interpreting.
Yeah, that's,
So you want to use that script that was on page, I think 86, maybe?
yeah, and Nicole, that's like really close. I think I would probably give you credit for that. Although the first part of the sentence we don't want. We don't want you to say the mean is this and the standard deviation is this. That part, throw away.
I put, we expect the average gas prices to be $6.48 in the US. Like currency per gallon, give or take $1.32 in US dollars per gallon.
Nice. That's nice. That's good. Yes. It feels weird, doesn't it? Because you don't want to write the same thing as everyone else, because we all want to be unique. Don't be unique in this part. Oh,
And Cindy was right. It is page 86.
so if you look at page 86, what I'll try to do is write the parts that you're going to write, or that's just always going to be the same in red, and then in blue, I'll write the parts that you are writing. So maybe I should talk about why this structure is the way it is. Like this, we expect, it's stat speak, right? Because in statistics, you don't know anything. We are guessing. So this is it's almost like legalese, right? You're very careful about what you say is real and what isn't real. This is just saying, hey, based on the numbers, this is what we think. This is our prediction. So what are we expecting to happen? Well, we go up here to the context and we look at what is the data. It's the average US dollars per gallon. And we were told to do this for the 2022. So we expect the average US copy and paste, the average price, there we go. The average price. And you could put in, oh, I was supposed to do blue. We expect, come on now, the average price, and here the context is gas, so the average price of gas, and then back to the sentence script, to be, and then the part that we got from right here. Don't use the median, even though if it's skewed, you should have. 648. And here's where you could add in the units, dollars per gallon. And I should stop being, what is it? Like the US is all that matters, and put in the point that it's US dollars. I wouldn't be picky about that. If you just put a dollar sign, that's fine. And then back to the part that is scripted, give or take. I tend to put in plus or minus here because it's less writing. Look at all that space. Whereas if I just put in this plus or minus, that's way less space. And then smash in that, was it $1.32 or was it $1.75? I don't remember.
$1.32.
$1.32. The standard deviation, $1.32, and US dollars per gallon. And if you put dollars over here, like you typically do per gallon, perfect. Yep, love it, Laura. Yep, that's perfect too. So you're going to do that every single time. And the parts in red are the parts that's the structure. And then the parts in blue are the parts you're picking out. So you're reading this part. So that's a reading job. And that's always in the paragraph prompt. And then these two are calculations. Or we've handed it to you and we just want you to interpret it. Now, remember, we said that this sentence is only valid if it's normally distributed, if it's a symmetric data set. If it's skewed, then the average price is really technically the median, right? That's the correct measure of average. And then this give or take thing doesn't apply at all because you can't use the empirical rule. So what did you say for H? What appeared to be the distribution of the data set? I'll help you too if you're feeling shy. You have a 33% chance of guessing it right. It's either skewed right, symmetric, or skewed left.
Wouldn't it be skewed left because the mean increased as, well, the standard deviation as well increased in 2022?
Ooh, I love your thinking. It doesn't matter what happened in 2017. Shape is only the relationship between the mean and the median. So we've got a vote for left and 2 votes for right. And I need to make it, how do I make it so I see who's talking? So I see, there's a way to do that somehow, whatever. So I need the explanation. No one has given me the correct explanation. And there's only one explanation you can give for this, although I guess we could try to draw a histogram of this, but that'd be really difficult. It's a really small sample, so that's not super helpful.
Isn't it because the mean is greater than the median?
Love it. That's what you look for. So we're saying that the mean is greater than the median. How do we know? The mean is 648. The median is 613. Now, this is that thing I talked about before where context matters. It's only a few cents difference, right? Like 35 cents difference. Is that a significant difference? Or should we say, oh, $6.48 is about the same as $6.13. Like, who cares? 35 cents is nothing. What's your arguments?
35 cents is everything when it comes to gas. Let's be honest here.
Yes, because it's the price per gallon. And if you're driving your 100-gallon Hummer, that's a ton of money, right? That's like, what, $35 for that fill-up difference? Yes, so I totally agree that in this context, a 35-cent per gallon difference is huge. If it was the price for a cup of coffee, we might argue that these are about the same, right? Like, yeah, it's a one-time thing and not a big deal. Okay, so skewed left because this, which means this statement is garbage. It's not true. The average price of gas is actually $6.13.
Eric, change that to skewed right.
Okay, thank you.
I don't want to confuse them.
Yes, yes. And just to help us all feel better, let's remind ourselves what page in the notes that would also be on. It's in 3.1, I think, is where we first encountered the relationship here. That's page 78. Here, where the mean is greater than the median, it's a right skew. This is a left.
We have a better page coming up.
Magic. Yes. Okay, how are we feeling? Is that anyone got whiplash yet? Because I'm jumping around so much, or are we all good? So I paused for 1 second and no one responded. That means I'm going to infer that all 100% of you know this. Yeah, okay, I'll keep going. There we go. One out of 6 means everyone's comfortable and happy, right? You all got to speak. Okay. I would love to give you 10 minutes to attempt this page. Quick reminder that when you're doing this, you need to draw this whole thing. So you need all of this. You need to put in these things. And you need to put in these things. And I'm being super messy and sloppy because you are copying this. That's page 263. All right, so a timer for, we'll do 10 minutes and see where we're going. And you can tell that I can't last for 10 minutes. I'll probably chime in 5 minutes and say, how's everyone doing? Set a timer for 10 minutes. One note, pay very close attention to this word. I just want to jump in real quick and make sure everyone got A, because if you can't get A, you can't do the rest. Does everyone know the answer to A?
Yes, Nicole.
Good, good. All right, carry on. I'll get out of your way. How's everyone doing? Should we talk about this part, or anyone stuck, or you all just got the answers? I know I've got, how much time left? 36 seconds.
I'm a little stuck myself, so if we could review, that would be aces.
Good. Let's do
Eric,
it.
can you, when you put the percentages on, I know one thing that I ran out of time and I did not show them, that is the, like, going over the top, that the first two were 68, 95, 99.7. Just,
Definitely.
yeah. We got all the percentages and answered questions, but I know for the day class, night class, we did have time to do that. Because I took up another 8 minutes of them. Went over.
That's 16 free minutes.
I know.
That's amazing.
I'm sure they're keeping track too.
Okay, so this part that I'm doing right now, I'm hopeful you all get that you don't need to think about this. This is just the theory. Theoretically, if a data set is, where does it say it? If you're told that a data set is approximately bell-shaped, another word for bell-shaped is normally distributed, which we'll learn about later. Normally distributed. Symmetric, by the way, is not necessarily bell-shaped. It could be uniform. So that's symmetric is a general term. Bell-shaped and normally distributed are specific terms. So is everyone good with these percentages? Do you all know where I'm getting them from? Do you get why you don't need to think about it? Okay, good. So what Cindy's talking about is the empirical rule that states, nope, we'll get there. Oh, it's 263. That says, hey, 68% of the data is within 2 standard deviations of the mean. That means from here to here, from this first standard deviation above and this first standard deviation below, that's 68%. And that should make sense, because if you look at these two percentages, we add them together and we get 68%. And then 2 standard deviations, well, let's change colors. Why not? How about whatever this color is? That's like this. And that represents 95%. Between plus or minus 2 standard deviations. And then the final one is the plus or minus 3. So let's go back to our worksheet here, and we can note that. So from here to here, that's 68%. From then here to here, that's 95. And if you're not believing it, add 13.5 plus 34 plus 34 plus 13.5, you get 95. And then the last one, which I'll do like way down here, is 3 standard deviations above and below the mean. And that's the 99.9% of the data. So our job was to fill in these things. First question we need to determine is, what is the mean of the data set? And maybe a better question is, where do you find it? Shout it out, y'all. Maybe you, or shout out that you don't know the mean, whichever one you want.
I'll be honest, I ain't got a clue.
Love it. Thank you for saying that. This one's tricky. Let me read the problem to you, because the mean is here. We just have to find it. So we got in a large sample of customer accounts. Ooh, well, that tells us something. It says sample. That means this is the wrong symbol. This should say S. Although lots of times we think about this as a population. So in a large sample of customer accounts, Consumers Energy determined that the, let's pause right here. What does this word mean? Average. What do we mean by average here? Oh, sorry. Here I'm waiting. Oh, good. Reagan, how did you know it was the mean?
Cause it's like the same thing when you add it all up and then divide by how many there are. It's like the words kind of mean the same thing, mean and average. At least that's what I think.
You're 100% right. But also a little bit wrong, because when we use the word average, we're talking about, in this class, most people, when they say average, is exactly what you said, Regan, is add them all up, divide by how many. This is another word for the word center. So it's a general word that could be the mean, it could be the median, or it could be the mode, right? It could be any of those three. You're 100% right that it's the mean, and the reason is because of the shape of the data set. It's approximately bell-shaped, meaning it's symmetric, so the best measure of average is mean. Now, here's the other part that's tricky about this problem. Where is the number for the mean? Like, what is it? And if you read, it says right here that the average number of days between when a bill was sent out and when the payment was made is 32. If I deleted all of this context and I read it, Consumers Energy determined that the average is 32 days. That might make it easier to note that, hey, our X bar, since it said large sample, is 32 days. And then with a variance of 49 days, that told us this is the square root of 49 days squared. Look at that craziness. What is days squared? No idea. But the standard deviation is meaningful, 7 days. How do y'all feel about that?
Not good about that.
Talk to me. What doesn't feel good?
This is something I've always struggled with, even back when I was doing stuff in school, in high school. It's a story problem to me. And when you add all the words in there, that's when I get confused. I can
So-
do the math. It's just finding the right numbers for me.
Yes. And I'm going to say that in, let's say, 4 weeks, we'll check back in and see how much you think you still feel that way. I'm going to try to model what I'm doing here of how to read math. Remind me to do this more often, where I read through the prompt, because I've kind of been skipping it too, forgetting that that's almost the most important part of this class. And I think having a highlighter, I know Alana does this when she does the notes. I know Cindy does it with the notes. Having a highlighter and saying, here's a word that's important, here's a word that's important, here's a word that's important, and here's some numbers that are attached to those words. Oh, these 3 words are important too. And then kind of like wading through all the other mess. There's some problems where there's like a whole paragraph prompt that we don't really need. It's just helps it be interesting. So Laura, you're not alone. Most students feel that way, but practicing the reading and helping me, or me helping to state, here's how best to read. It is a skill. Like, it's totally different than reading a novel. Totally different. Okay, so let's now fill in these things. So here's where the math comes. We know that the center of the normal curve, as you all said in the chat there, is the mean. So that means 32 goes right there. And this might get to your question, Nicole, about where does 53 days come into play? How do we figure out these numbers here? What do we do? And how do we figure out what numbers these are?
When we go towards the right, it's addition, and we go towards the other way, it's subtraction.
Love it. Addition and subtraction of what number specifically?
The square root of 49, the 7 days.
That's it. The standard deviation, which in this case is 7. In fact, if we go back to your reference sheet thing on page 263 real fast, if you zoom in and you note, look at this. This says take whatever the center is, take the mean, and add to it 1 standard deviation, whatever that number is. And then here says add it twice, which is the same as adding the standard deviation to this. Then you'll have added it twice to this. And likewise, here you're subtracting. That's what that thing is telling you down there. So back to our worksheet. Here comes the +7. So 32 plus 7 is, I believe, 39. +7 again is 46. +7 again is 53. There's the 53. That means 53 is 3 standard deviations above the mean. And then for this direction, we're going to subtract what, 25? 32 minus 20, 32 minus 7 is 25. Subtract 7 from this gets us to 18. Subtract 7 from that gets us to 11. How are we doing?
All hope is not lost.
Okay, I have a question. Is it always gonna tell us like the mean or median, the number that's gonna be in the middle, or are we sometimes gonna have to figure that out?
Great question. If I give you a blank graph like this and I say, draw this for the, whatever this says, draw a reasonable picture with the parameters and percentages properly marked and labeled up to 3 standard deviations from the mean. I have to hand you the mean and the standard deviation somehow. I have to give it to you. Otherwise, you can't draw this. So I could give it to you like this problem did in the prompt, or I could give you a data set and you have to draw it from there. But I think 99 up to 100% of the time, we're going to tell you the mean and standard deviation, and you're going to fill this out. So now we have a graph and we just need to know how to read it. There you go, page 91. So note this says roughly 68% of all customers are paid between what time frames? Here's what I want you to note in your head. For this particular problem, these numbers down here represent time frames because they're days. These numbers over here represent percentages or probabilities. So when we say 60% of all customers are paid between what time frames, we're looking at, oh, here's the 68%. Go down to the x-axis. Oh, it's between 25 days and 39 days, plus or minus 1 standard deviation. Now, the most technical way to write it is with interval notation. Don't worry about that now. You can use the dash mark. As Laura's put in the chat, that's fine too. You should probably put days, but I haven't been known to mark off if you forget days. I really should, to help you keep track of the units. Awesome. Okay, so then how about this one? Note this says, hey, what percent? Estimate it. By the way, all of these percentages up here are estimates. That's why we use the word estimate here. So estimate the percentage of customer accounts for which payment is made between this 32 and this 53. What did you all do?
Added,
Love it. Nicole,
but
you're
it's
so
not
close.
the full 50% though either, because that 0.15 is after the 53.
That's it.
So
Good.
it's 49.85%.
Yeah, so there's a couple ways you could do it. You could do the 34, which is between 32 and 39, plus the 13.5%, which is between the 39 and 46, and then plus the 2.35%, which is between the 46 and 53. And that is, yes, 49.85%. Maybe you rounded that up to 50. If you did that, don't ever round these percentages. These are already estimates. The other thing you could do, which isn't mentioned here, but it's kind of given in the notes, 50% of the data is above the mean. and 50% is below. So you could note that, oh, 32 to 53 is all of these except for that 0.15. So you could have done 50% minus 0.15% and you'd get the same thing. Either way, it doesn't particularly matter.
So are we ever gonna use that 0.15%?
It depends on what we ask you. What if I said, what percent take more than 53 days?
Okay, so
And that's,
got it. So if it's to like the number, you don't do anything after that, just the in between. Okay,
yes. For now, and like in the midterm, we're exclusively using these standard deviations. When we get to chapter, oh, maybe this is on the midterm. When we get to chapters 6 and 7, we're going to find like, what percent are below 36? Right now, it's impossible for you to figure that out. We're going to use StatCrunch to calculate that percentage. That's coming. But for now, just get comfortable reading the x-axis and the percentages and knowing what they represent. Remember that percentages really mean probability. We're going to talk about that a lot later. How about 46 days or less? What percent do that? Now, this is getting really messy up here. Let me clean some of it. So 46 days or less. How do we answer that? Let me draw in the picture. You can also say, I have no clue. I'm happy with that. Here's the 46 days. It said less. So the less than part is all of this.
So yes, Laura. Yes,
Oh.
Nicole.
Oh. Or I could just read the chat and note that you won't be telling the answers. Good. So we could take 100% and subtract 2.5 from it. Or we could add up all of these. Either way we get it. And what did we say? 97.5%? Is our final answer? Awesome. Awesome. Okay. It feels good, doesn't it? Like, so this, the first time students see this, it's like, what? Because you've never ever seen anything like this in your life, most likely. I teach this in the quantitative reasoning course. And students always do one way or the other. Either they miserably fail it because they have no clue what's going on, or they crush it because they bothered to take some time to run through it. So yes, you're going to love this. Now, can someone remind me the definition of unusual? I'm just gonna put a star here and someone tell me something about what does it mean to be unusual?
The data value has a less than 5% chance of happening.
Love it, love it.
That's what it
Or
says.
a data value is more than 2 standard deviations away from the mean. Okay, good. I just wanted to note, like, hey, look, this is what you're being asked. When I say, is it unusual? You're being asked to use one of these 2 answers to determine yes or no. Trying to connect the things I wrote down to the questions you're being asked. All right, so how do we do this? First, figure out what percent is less than 18 days, or what standard deviation. What do you all say?
Well, it's less than the 2, so that makes it unusual. Yes.
Good.
No. Yes.
Yeah, no, 100% correct. Yep. So, and in this case, we actually know both things, right? We know what percent is less than 18. It's this, 2.5%. We also know that 18 is exactly 2 standard deviations below the mean. Let's leave that at 0, right? So these numbers here that I'm writing in is the number of standard deviations away from the mean each of these numbers are. So the mean is the mean, so it's 0 units away from itself. This 25 was 1 standard deviation below because we subtracted 7 from 32. This 18 is 2 standard deviations below because we subtracted 7 twice. So your answer is acceptable to say yes, number 1. That's 1 point. Number 2 is the explanation, and it's either 2.5% of the data are less than, no, let's not say it that way. Let's just copy the definition. It's either less than 5% of the data, are below 18, or either one is correct. You don't need both. 18 is 2 standard deviations below the mean, and that's how we define things being unusual.
So you guys, if they did not have the word less than in there and they just said, would it be unusual for a customer to pay in 18 days and didn't have less than, and it's exactly 2 standard deviations? If we look at our what Eric just wrote, he said below the mean, more than 2 standard deviations away from the mean. So if it was exact, this is a kind of a tricky one. If it's exactly 2 standard deviations, remember we kind of talked about that, then it's not unusual. So if they really wanted to be tricky in this one, they could have said, well, what happens if it's exactly at 18? Then it's not unusual. So it has to be beyond 2 standard deviations. So because they wrote the word less than in there, that's what made it unusual.
Does that make sense, y'all? Yeah, that's a really, it'll crop up like once or twice somewhere. We're going to throw that at you. Be like, hey, is it unusual to be 18? And you're like, no.
I'm pretty sure we have a worksheet where, that it gets kind of tricky.
So it has to be below. Yeah.
It has to be below that 2 standard deviation.
Awesome. See, 32 minutes. Let's just talk through these next 2, okay? Because these are they're more conceptual and they're pretty straightforward, and except that it's a trick to make sure you're catching things. So let's do our reading, and let me highlight how to read math stuff. So the following histogram. All right, when I hear the word histogram, I think this is quantitative data. I think this is classes of things. So there's numbers that are between these. It looks like, Laura, this goes to what we were talking about this morning. It looks like this 44 is a midpoint for this class. This 41 appears to be a midpoint for that class. So I've got that running through my head. So it's a data set. I see that it has a mean of 50 and a standard deviation of 3.5. I don't particularly know whether this is a population or a sample. So I don't know if I should write mu equals 50 and sigma equals 3.5, or if I should write S equals and X bar equals. I also don't even know yet if it matters from this first sentence, but I've got all that information floating around in my head, right? Then we get to a question. Is it appropriate to use the empirical rule? Okay, I pause here and I remind myself what the empirical rule says. It says, if a data set is symmetric or approximately bell-shaped, Then I know that 68% of the data is plus or minus 1 standard deviations from the mean. 95% of the data is plus or minus 2 standard deviations from the mean. 99.9% of the data is plus or minus 3 standard deviations from the mean. I know I can draw this shape and I can do this mess and this and this and this. How's everyone doing so far?
Good, makes sense.
Good. So what I'm demonstrating is when I read these words, these are the things that come to mind. Now, if these things don't come to mind for you right away, I'm guessing that's probably true. It's because you haven't been doing this for the past 20 years of your life or however long I've been doing this. So your job would be to like, oh, empirical rule. I don't remember what that means. Quick, look it up. It's in your reference sheet, right? If you're forgetting mean, think, oh, that's average, a measure of average. Standard deviation is a measure of spread. Histogram, look those things up. Now, here's the thing. Is it appropriate to approximate the proportion? Now, this is a word that messes with people, I think. Proportion is, in this context, just another word for percent. And then it says of the data between 43 and 57. Now, those two numbers, you might be wondering, where did they come from? It actually doesn't matter in this context, but if it did, by the way, it says, if so, find the approximation. We could quickly do what we just did. The mean is the center. The standard deviation gets added to that. Oh, there's my 57. What is this? 47.5, 43. Oh, there's my 50. So this is a minus 2 standard deviations below the mean. This is a plus 2 standard deviations above the mean. So that's 95% of the data. But the question says, is it appropriate? So we go back to the empirical rule. What must be true about the shape of the data set in order to use the empirical rule?
It needs to be symmetrical.
Talk to me about this histogram.
It's skewed left.
Okay, so guess what? None of that applies. We did all that to just say, is it appropriate to use the empirical rule? No. The data are skewed left. Done. But did you see all of the things we had to think through in order to get to that answer that no, we can't do any of this because our data set is not symmetric?
Yes, I appreciate that. That's where I struggle the most.
It takes time. Like I said, I've taught this class, I've probably done 50 sections of this. So it's not fair that when I read this, it all comes out in my head, right? And I'm just like, hey, just be me and you'll be good. No one wants to be that. Awesome. This highlights that you need to keep track of the empirical rule and when you can use it. Most often the questions we ask about the empirical rule, the data set is bell-shaped and you do your thing. But keep that in mind. There are rules that must be followed to use the rules. All right, next one. Which distribution? Let me pause here. Remember, distribution is like a way to organize the data set. It could come in the form of a table or it could come in the form of a graph. Right now, we're seeing two graphs that are histograms. So these are the distributions, graph 1 and graph 2, or I'm sorry, they're lettered already, graph A and graph B. So I know what the question is asking. It's asking about these two graphs, and we are to pick which one has more variability. Pause. What does variability mean? Or maybe we should say, how is it measured? Oops, don't pause because it's said right here, by the standard deviation. Yikes. But remember, variability is a measure of spread or dispersion, and we have 4 options. It could be range. It could be the one we're asked to think about, standard deviation. It could be variance, or it could be IQR, any of those 4 things. Here, we're told, oh, both of these data sets have a mean of 3. So what do we want to use? X bar equals 3, X bar equals 3. So we're asking which one is more spread out. What do you all think?
The second one, graph B.
Now, why do you think that? I agree to think that, but why? What told you that one?
Because it's showing more frequency and it also has that bell shape to it.
Nice. So this one's bell-shaped. What shape is this one?
Nothing.
It's the-
Concrete.
It's the one that we don't talk about much. This one's uniform. Now, let me step back and we'll do a conceptual definition of spread. Spread is how far away, it's a measurement of how far away all of the data values are from the center when we talk about standard deviation. In fact, standard deviation is the average distance all of the data values are from the middle. Now, if you look at these histograms, notice this says frequency. So what that's telling us is in this first class, or this first bar here, the data value appears to be 1, and there's 10 of them. Now, 1 is the furthest you can be from the mean. 5 is also the furthest you can be from the mean. So there are 10 data values at 1, 10 data values at 5, and they are far away from our 3, which is 10 values. Now let's compare that to data set B. Notice here there are 5 data values that are the furthest away from 3. And here there are 5 data values that are the furthest away from 3. What do you think about what I just said? Was that just crazy talk? I mean, if you're super upset that you're being flicked off right now, getting the middle finger from data set B, I hear you. Take, breathe. They're not angry at you. This is the isn't there a country where the middle finger is like, hi, how you doing? Or like, have a good day. Isn't that true? And then isn't like thumbs up like a bad one somewhere? So the correct answer here is actually A, because there are more data values further away from the mean. Now, pause and tell me if that is helpful or if that makes sense to you.
Because you pointed out the 10 and 10 instead of the 5 and 5.
And Laura, I 100%, like 90% of students, when they do this question, they're like, B looks more spread out because it's the shape, right? It's a middle finger. So it looks more spread, but it's actually the opposite, because what's happened is more of the data values are exactly equal to the mean. So the standard deviation of this is going to be less because the distance between all of these 3s and the center is 0. Whereas all of these distances are a number, some number. So, okay, let's not spend too much more time on this, but that's that one.
Oh, it's because it's A because the standard deviations, like there's less or there's more of them by
Well,
the mean.
When we calculate the distance, all of these data values are from the center. The average of all those distances is going to be larger than this. In other words, the standard deviation of this one, we'll call it S, is greater than the standard deviation of this one. And that's where like looking at the formula could be helpful. What you do is you subtract the mean from each data value, square that, add up all those distances, divide by how many, blah, blah, blah. And it's getting the average distance each number is from this center. How far apart are they?
So you guys, oh, sorry, Eric.
Go,
If you
Cindy,
guys
go.
go back and look at page 89 in our notes when we did this. And we went and where we labeled them in order from smallest to largest. And we talked about why they were from smallest to greatest.
Awesome, awesome.
Out, get down.
And it all has to do, like, I get the uniform one because it looks like, oh, they're all the same. They all have the same amount of data values. So you want to think it's that one, but what you want to think about is the frequency versus the picture per se. Okay, we have 15 minutes. Is there anything still confusing about any of this worksheet that we should talk about? This worksheet is due Sunday, the 18th. You've now completed it, so you can scan it and put it in. I did want to say that I have graded one worksheet that y'all turned in. I graded the 1-1 worksheet during this morning. And I want to make sure everyone looks in there. There was a couple people that submitted the wrong worksheet. So I put in a 0 and just said, please resubmit the correct one. So you did worksheet 1.1 number 1 instead of number 3. Not a big deal. Don't worry that it's a 0, just upload the correct one. Some people, only the first page showed up and not the second page. So some people lost 9 points because the second page wasn't there for whatever reason. And again, I just said, hey, submit the second page and I'll regrade it. Some people forgot to fill out a section. And I just said, hey, this part there weren't any answers for this. Fill it in and I'll regrade it. I want to make sure everyone looks at that so you get comfortable with, or good with submitting and how it shows up and how to read feedback from me. There's not a lot of feedback on that, but check that out. I'm hoping to, well, I will be grading everything else as I go. I got to get caught up. Some people, it told me how late it was. You all submitted it, and I didn't care. But if there was nothing submitted, I put in a 0 so that we all know that I graded it and that's where you stand. And that's generally what's going to happen. I will grade the assignments. When I sit down, I'll grade all of a particular worksheet. And if there's nothing submitted when I sit down to grade it, which by the way is always after the due date, hopefully a day or two, but this time it was like a week. I'm going to put in a 0 so that you know, hey, you never turned it in. It's hurting your grade. Turn it in. That's all that matters. Just turn it in. Turn it in once you've done it and completed it and feel good about it. Questions about that?
So can you show them the 3.2 worksheet number 2 that they need to do for me? So you guys, I only have 2 worksheets this week that I'm going to have you do for me. And this is one. So this should look very familiar. Another practice of the empirical rule.
Do your practice of highlighting the things you need to know in the drawing. Yeah, so that one, same question we just did. This one's a little different.
This is different. Yeah, this is actually just like a bar graph or histogram.
Notice the labeling here is different. Some of them, they do 0, 9. Well, no, the 9 wouldn't go on there. They do, if they had labeled this the way the other worksheets have been, it would look like this. 0, 10, 20, 30. But instead they're labeling the lower and upper limits of the classes for each bar. So that's kind of a different thing. One note, my in-person class talked about this one a little bit. Assuming there are very few residents, that means think of this as approximately 0. Estimate the total population of the state. Great practice. There's no stat crunch practice on that, but that's fine. We're going to get plenty of it in 3.3. The thing we're going to do in class on Wednesday is we're going to do the 3.3 worksheet, and we're going to look at these chapter 2, these projects. So we're going to
Yes,
attempt to do
please
that.
do
all
that.
in.
3.2 worksheet number 2 as homework.
And I would say try to do it before class tomorrow with Cindy so that you can test, hey, has this sunk in what we did here? Does it make sense? And then if you get stuck on something, I don't know, well, you might not have time to go over it, but you could bring it to class on Wednesday and we could look at it, any of these questions.
Is it okay if I'm highlighting stuff on my homework assignments to help
Please
me
do.
point out the words and stuff?
Absolutely.
Okay.
Absolutely.
Yes. I would love to see you turn in an assignment that looks like this. Well, like this, where you've highlighted all these things and you, as long as when you take a
mess?
picture,
Got
it's
it.
clear.
I can do that.
Yeah, it's okay. It may, you know, maybe like box in an answer if it's super hidden, but I'll find it. Let's talk about my stat lab real quick. So you have homework assignments for Cindy, and you have quiz assignments for me that I've never messed with the due dates for.
I put in due dates for you.
Oh, thank you, Cindy. So I believe our first quiz is showing up as a due date.
Which was due this past Sunday.
Which was due Sunday.
But they can work past the due dates with no penalty.
And it looks like not a lot of
Oh.
people completed it, 7 out of 20. So please try to get in there and do that quiz, this gold star thing. And I would like to talk on Thursday how you're feeling about the workload between the quizzes, the homework, the worksheets, and the notes. And what I'm interested in is how much all of these things are helping to contribute to your learning and understanding of the material. And if it's too much or too little or just right. That's like a Berenstain Bears book, when the new hat, old hat. And I think when you think about this, you need to be careful to think about how much time are you setting aside? Like, how have you structured your life so that you know you've got this much time to sit down and learn the material by doing homework and notes and things? And how much of it is you just don't have time, and so this feels like too much? Because I want to make sure we're balanced here, and that you are progressing and learning and not getting to the point that all of the work becomes busy work and it's not learning. Do you all understand what I'm getting at?
I understand what you're saying. I don't mind sharing with everyone what I said
Please.
this morning. I have 5 children. I'm married. I have 3 dogs, and I'm a cheerleading coach, and I have 12 credit hours. On top of these 2 statistics classes, I'm taking anatomy and physiology. But at the same time, without like I said, I'm not the best at math. So for me personally, I need the repetition of my stat lab. It is tedious, it is tough, and I didn't want to bother either one of you over the weekend. So I did end up going on to what's her name again, Eric, on YouTube?
Oh, Lana Tucky?
Yeah,
Alana Tucky. I actually did watch one of her videos and I rewatched one of our recordings as well. But I think without the repetition, for me personally, I don't think I would completely understand the material.
I should say the homework assignments are non-negotiable. Those are going to be here. What I'm thinking about specifically are the quizzes. That
how have you done the quiz, Laura?
I have not done the chapter 2 quiz because I did have some questions that I came to tutoring session this morning to talk with Eric about. But I will be doing that either later this afternoon or tomorrow.
My feeling, Eric, from what I got from students over the weekend is that the quizzes were much harder than all of the other things that we had been doing. And so they were getting frustrated with the quizzes. So I'm thinking, I don't want to say it out loud here, but you're kind of what you were thinking before. I think with the amount of worksheets that we're doing, and we're doing more than what a regular stats class is doing, because you're doing some, I'm doing some. I feel that the worksheets are a better representation of what they're going to see like on midterm final. So I feel like if you want to use homework grades as your My Stat Lab, it's only 10%. I feel like we can get rid of those quizzes. They are more difficult.
yes, and
Just
they're
the
longer, and you have
But
to redo
I
it.
think Laura's right. The homework is good because it is repetition and they can learn from that. But those quizzes are extremely, I don't know how many people got a hold of me and said, I spent an hour and a half, 2 hours, 3 hours on it, and I got a 70% and I feel defeated. And that's not what we want.
Yeah.
That's my feeling, and I was going to
Okay.
talk to you about it. So I feel like we continue doing the amount of worksheets that we're doing. And yes, that means that you guys are going to have, you're going to have maybe some more worksheets that you're going to have to do outside of class, but then we can take away those quizzes in My Stat Lab and instead concentrate more on the worksheets. And you know, just realize that, you know, Eric and I don't have time to do all of the worksheets, so you are going to have to do some, but we can just unassign.
I think the two things to me that are challenging about the quizzes, and I'm 100% on board that we should maybe just get rid of them, is if you get anything wrong here, you have to do every single question. And that takes a lot more time if you're really wanting that 100%. And then with the homework, you can go and pick individual questions to redo to get 100%. So I like that structure a lot better. So let's just do that. For those of you that did the quizzes and got them done, I hope you don't feel like, man, I did all that work for nothing and now I don't have to do them.
It was wonderful practice and you got a lot of knowledge.
And you're helping everyone and yourself by saying, let's not do the rest of them. So
You won't have to do that again.
Yes. Okay. Right. Good. Hopefully
You guys,
you're all
I
feeling
will
good about
tell
that.
you that the majority of the stats classes, like I've never had a class not do the quizzes. So you guys don't go out and broadcast, we're not doing quizzes. You don't need to do that. But you guys are doing more worksheets. But I just feel like after the comments that I got over the weekend, these quizzes, they're not going to be like the wording that you're going to see on midterm final. We'll go in there and just go in there and get rid of them. So we'll
Awesome.
assign those.
So we don't need to talk anymore about it then. We've done it.
Yeah, we talked about it. You guys
Okay.
made the decision.
You made it. Yes, it's your fault. Awesome. So I gotta head off to my next class.
Yeah, I'll unassign them, Eric.
Okay. We'll get those unassigned, so don't worry about them. What will happen in 133 is your homework grade is gonna count in both classes. So I'm
So
gonna
do,
take,
do get on your blue circles.
yes, do that. You have to. That's 10% of your 133 grade and your 033. It's double
It's
jeopardy.
25% of their 033 grade.
Okay, it's 25% there. So, okay, so make sure you do it.
All right, we'll let you get to class.
Okay, y'all.